Recently, Austin Evans made a video where he broke some electronics using a USB killer. So I reached out and asked him if he would send them over my way to see if I could fix them. And he said he would. So I have all the boxes. I'm not even sure what all he sent. So let's get them opened up and find out. And here is box number 1. Let's see what we have. Okay, looks like a laptop. What is this, a Toughbook? I don't remember if that's what they're called or not, but dead USB kill. So we've got one laptop, and what is in box number 2? A PlayStation 5. So this is the 1100 model, and it does not work. Oh, what else? We also have, looks like he threw in an Apple iPhone. All right, we'll have a look at that as well. So far we have a laptop, an iPhone, and a PS5. Let's see what's in the last box. Okay, and we have another laptop. I feel like that one gave me a shock just pulling it out of the box. And another laptop, a Chromebook, okay. What else do we have in here? Another, oh, is this a tablet? Nope. Oh, here we go. We got a MacBook Air, it looks like. Okay, so that's gonna be a fun one. That's actually in really nice condition too. All right, and we have a Nintendo Switch Lite, and this one has the translucent purple case on it. That's cool. What else we have in here? One more laptop, and this is an older MacBook Pro. So we've got our work cut out for us today. I think now is an appropriate time to say, I'm not a laptop technician. I've fixed a few. I've tried to fix a bunch that I couldn't. So I don't know how this is gonna go, but let's get started and see if we can fix any of these devices. So let's start with this Lenovo Chromebook. Got a USB meter set up. Let's see what happens when we try to charge it. Okay, it just turns off. Let's see that again. Yeah, just turns off right away. Let's just see what happens when we plug it in on this side. 5 volts, 0 amps. Yeah, so just nothing going on over here. Okay, let's get this thing taken apart and see if we can figure out what's going on. It's gonna be interesting to see if we can find any burned chips or anything in here. Okay, here we go. Let's see what it looks like. So right over here is the charge port. So I need to get this main board out so we can have a look at the other side. And we need to make sure and disconnect the battery. Should have done this first, but I didn't think about it. And now all the other little ribbon cables. Okay, now we should be close. Nope, what's holding this thing down now? Of course, the warranty screw. Now this thing right here just would not pull out. It needs to, but it didn't wanna. And I'm not sure why. I feel like it's glued or something. There we go. I don't know why that was so hard. Okay, now we can take a look at the other side of this board and see if we can figure out what's going on. And here we are under the microscope. This is the USB port that the USB killer was plugged into. And how a USB killer works is it takes power from the device and stores it in very strong capacitors inside the USB killer itself, and then it pushes that power back into the motherboard all at once, and that causes components to blow out. So the first thing we're going to be looking for is any fuses or resistors that might be blown, and I'm just taking a look at the board right now just to see if there's anything that looks obviously blown. This 0 ohm resistor right here could be acting as a fuse. Let's check that real quick. And we get 0.8 ohms, so that is just fine. Now this component, this slim port ANX3429, that definitely could be a problem. This is sort of the power controller. Let's check this resistor, 122. 1.19 kilo ohms, that looks just fine. I'm gonna change over to audible mode. So now we're gonna hear a beep whenever there is a short to ground. So there is a short to ground on the case of the USB port, which we would expect. Let's check all these lines. Okay, no surprises so far. Unfortunately, without a schematic, there's no way for me to really know whether some of these should be shorted to ground or not. Usually a big coil like this wouldn't be, but it's just really hard to know. Let's check this control power management chip. And again, I'm just checking to see if there's a bunch of pins shorted out or something. So far, there's definitely not. Doesn't mean it's not bad, but a lot of times when these go bad, there'll be a large amount of those pins shorted out. So I don't see anything obvious other than possibly this big coil right here. Let's check this big coil over here. Yeah, that one's not shorted out. Let's check this capacitor. That's fine. Diode's fine. So really the only thing that I'm kind of not sure about is this guy right here. So given the fact that this chip just doesn't have really any shorts on it, I think what I want to focus on is this area up here. So this coil is shorted to ground on both sides, and these pins are all shorted to ground as well. So is this 0 ohm resistor. That is shorted to ground. So I think what I want to try and do is remove this chip right here. I don't know what all is on this circuit that could be shorted, but this looks like probably the most likely cause, but there's just no way for me to know for sure, especially since I don't have any schematics for this board. So let's try that and just see what happens. So I'm using my hot air soldering station to heat up the board and that chip until the solder melts, and that will enable me to lift the chip off the board, and then we can see if any of those shorts are still there or not. There we go. And let's see if that short is still there. Yes, it is. Okay, so I'm going to remove this chip next and see if that does anything. And with that chip removed, let's recheck these shorts. Unfortunately, I don't like, it is possible that this is how these are supposed to be. Yep. Everything's the same. It is the downside of not having any schematics to go off of. So let's see what happens when we plug this into a charger with that chip removed. Here we go. Whoa, that is pretty up close. But you can say nothing at all happens. All right, so I'm gonna put this chip back on, and then actually I'll put both chips back on. Let's see what happens once those chips are back on. And I'm gonna add a little bit of flux to this. This will just help the solder flow. Now I'm going to come in and remove this little solder blob here. There we go. And then just make sure these are all soldered on nicely. Actually all looking pretty good. Yeah, and that short is still there. Again, not sure if it's supposed to be or not. But let's see what happens now when we plug our charger in. Just see if that happened to do anything at all. All right, and here we go. And we get the exact same problem. Now, unfortunately, I don't have one of these chips to replace it with. My guess is this chip is probably faulty. I definitely could be wrong, but without a schematic, there's just no way to really test it, and I can't find a data sheet anywhere for this chip. So unfortunately for this Chromebook, I can't say for sure what the problem is. I'm guessing that this chip took the brunt of the voltage coming in from the USB killer and probably killed this chip. Now, as you can see, there's a bunch of little lines going to the chip from the USB-C port. If there was some fuses on these lines, that could possibly prevent this problem, but unfortunately, manufacturers kind of cheap out on this kind of stuff and just don't install those fuses. So we're not starting out great, but let's move on to the Gateway laptop and see if we can fix that one. So let's just see if it happens to turn on. Where's the power button? There we go. Definitely no power. See what happens when we plug it in. Definitely no power. Okay, let's take the bottom cover off and see what's going on the inside. Okay, there we go. So that is where the power comes in, right over here. Definitely got some fingerprints over here, so this has been into before. Now let's get this board out so we can have a better look at it. Actually, before we do that though, let's try disconnecting the battery and then reconnecting it and just see if that does anything. I don't think it will, but you never know. Let's see if we have any voltage in the battery. 0 volts. Oh, 7.8. Okay, we got a little bit of voltage in there. So let's disconnect it. There we go. Let's see what happens if we try to plug the AC adapter in with the battery disconnected. No lights, no anything. Yep, no power at all. Okay, let's plug the battery back in. Now let's see what happens. I don't think that's going to do anything, but sometimes crazy things happen when you unplug it and plug it back in. Yep, nothing. All right, let's get this board out and have a look at it. All right, easy enough. Let's have a look and see if we can figure out what's going on with this one. So here is the AC in port, and this is where the power comes in. So let's check. We've got these two 0 ohm resistors that can act as a fuse. And there is no resistance there, which is good. And 0 there. I'm testing voltage. We need to be testing resistance on these. What am I even doing today? Okay, let's try this again. All right, 1 ohm, that's normal. And same there. So those are both good. That means that the inrush of voltage and current didn't blow these resistors. Let's just check for a short on these capacitors. Nope, good there. And let's check these MOSFETs here and see what we have. No shorts on those. Okay. I'm just looking around the board to see if there's any actual fuses here. Let's check over by the battery connector. So there's the battery connector. And there's a 000 resistor right there. And that is good. Okay, and one more over here. I don't think this has anything to do with the charging circuit, but let's just check it anyway. Yep, that is good. And this one is also good. Let's check this one. No problems there. So I am just seeing nothing obvious on this board that's blown or burned out. the next thing I'm going to do is actually plug in the AC adapter and let's see where we get voltage. Okay, there we go. Now we'll switch our meter over to DC voltage and let's see what we get. And we have 19 volts in, so we're good there. Let's check over here. 19 volts there. And I'm just going to do some checking around over here. Those don't have voltage, which isn't necessarily a problem. 18.9 on this guy. So no obvious problems there. Let's go over here to near the battery connector. And this guy right here is the charge controller. And we have voltage on this. I'm just kind of checking this thing for voltage and shorts. Just kind of, I don't know what this should look like when it's working. But if it was shorted, that definitely could be a problem, but I don't see that at all on this chip. It appears just from very rough prodding and poking that this is probably working fine. 20 volt, 24 volts out right there. Same there. 18 volts. So I think this chip is probably fine as well. So unfortunately, I just can't find anything obvious wrong on this board. None of the fuses or resistors that can act as fuses are blown, so all of that looks just fine. The charge circuit seems just fine. That being said, a proper laptop repair technician might be able to figure this out quickly, but I'm just not seeing anything obvious and I just have no leads as to what might have gone wrong with this board. So in this case, and on the previous laptop, the USB killer is a really covert way to kill a laptop board. Since this is kind of a cheapo laptop anyway, I think we're gonna stop here so we can put a little more time into things like the MacBooks. So let's move on to the next laptop. And the next laptop we have is this Dell Latitude Rugged. Well, let's see how rugged it is on the inside. Okay, definitely no power. Let's get this thing taken apart. This will be kind of cool to take apart. I've never taken one of these apart before. I've seen them around, but never owned one, never taken one apart, so this should be fun. Also, it looks like we're gonna have a number of different sizes of screws, which I never enjoy, but especially in this case, I do understand why they need to do it. This case is so crazy compared to what you see with most laptops. Ah, 3 different kinds of screws so far, come on! That's just mean. Just so many screws. Looks like this must be used to mount onto a mount or something. Wouldn't surprise me. This is probably what some law enforcement use, I would think, something like this. That's just based on, you know, peeking in their cars in parking lots. I'm sure you guys will know more about that than me as far as what they use. Okay, I think the seam is right along here, so that screw should be fine. This thing is difficult to get apart, that's for sure. Let's try from this front edge. Oh yeah, we already got some progress here. There we go, got one of them. And of course we have a hidden screw under the disk drive. There we go. Once this comes out, then we can get to that one. Okay, let's see how, whoa, wow, that's easy once we have all the screws out that need to come out. Alrighty then. And now this just lifts right off. Okay, holy cow. This is an intense laptop underneath that case. Okay, so where is the AC adapter even on this thing? I mean, clearly this is probably a port for power. when it's plugged into like a dock. But there we go. Right up here. Okay. This is a lot more intense inside than I was thinking it would be. Okay, so we need to inspect this guy and wherever it plugs into. I mean, we can't really see much yet. I don't see anything crazy going on here yet, but we can't really see the board very well. So I need to get a bunch more of this stuff off, and then we can have a look at the board. There we go. Gives us a little more access to the board, but still don't see anything too crazy going on. We need to get these guys out so we can see under there. And then we need to somehow get this whole board out, I feel like, because we got to be able to see this power input area. And I'm going to take a couple pictures first, just because this is a crazy laptop inside. This actually makes me want to buy one of these to do a repair video on in the future. It looks like it'd be kind of cool to do. Okay, and there's that one. I hope this has better, you know, some sort of better fuse or something, especially given that this does seem like some sort of, you know, law enforcement laptop. You would think that they would care a little bit more about having some protections from things like USB killers. There we go. We need to unplug this guy. Battery cable. Okay, so that means this is the battery. The battery shows that there's 4 bars. Okay, so definitely not a battery issue on this one. There we go. Easy enough. Oh, this just pulls up. We might not even need to remove the fan. Look at that. That is a pretty beefy heatsink for a laptop. That is very cool. There we go. And we have a little pull tab, which is always nice, but the pull tab doesn't really give you enough to pull on. So we're going to use a little bit of help here. There we go. Okay, display cable out of the way. Okay, and one screw holding the motherboard in right there. That's ridiculous, but not really a surprise. And we almost, sort of, maybe, have the motherboard. And of course there's ribbon cables connected underneath. Oh, that's ridiculous. I am not sure why that's necessary. Oh, here we go. Here we go. Okay. So that one can come out. And that one can come out. That's ridiculous. Okay, now we can set this part aside and have a look at this board. So in Austin Evans's video, this is the USB port that he plugged a USB kill into. I'm looking back here and these two little guys look like maybe there's a problem there. We'll get under a microscope in a second, but that we definitely do need to inspect that. Also, I'm seeing a number of places where there are fuses on this board. Anything with these zeros on them either are or can act as fuses. So that's looking promising there. I'm not sure why it doesn't turn on though. That's the main thing. And also in Austin Evans's video, you can hear the kind of like 2 clicks or 2 snaps when he plugs that device in. I'm wondering if it's from these guys here, but also where did that send power to make it just kill the whole computer? That's one of the main things that I'm going to be trying to figure out in this video. We have the DC in right here. That's what that connects right here, so we'll check that in a minute too. But right now let's just kind of look over the board and see if there's anything obvious that looks blown or burned or anything like that, other than those 2 little guys behind that USB port over there. And on this top side, I am not really seeing much. And on the bottom side, a number of fuses as well. We'll check those here in a minute, but just nothing that really looks burned or broken, or even sometimes components will have kind of a little bubble on the top. Nothing like that going on. So let's check all of these fuses and just see if we find any that are bad. So we'll start back here. That fuse is good for sure. Good. Good. Okay, no problems so far. Let me know in the comments if you see any fuses I miss, and I can come back to it if we can't fix this one. So that, I don't see any fuses that are blown, at least not obviously. Okay, let's try the back side. I keep hoping we'll find one of these fuses that's blown, because that would be an easy fix if that's all it was, but man. We are not having any luck so far. Okay. I just don't see anything that's acting as a fuse that is causing a problem. So let's get under our microscope and have a look at those two components by that USB port and see what they look like close up. And here we are under a microscope, and these little guys are just totally destroyed. These are probably the source of the two sounds that we hear in Austin Evans's video. And this, I mean, it's sort of good news because these blew, but also the computer also blew. So unfortunately, these or even this fuse didn't really do its job if the whole computer blew instead of just these guys. Having these two components blown like this shouldn't make the computer not turn on. So let's keep looking and see if we can figure out why it's not turning on. All right, let's plug it into power. Oh, we get some noise. That's strange. Let's see what we get on a thermal cam. Right there we have a problem. Maybe we've got 133 degrees right by that guy. Okay, let's unplug. We don't want to actually do any damage here. So that was right near this guy right here. I think it might be on the other side though. So right in here somewhere. Let's plug it back in. Yep, get the noise again. And we've got right there. 120, 127. Okay, so that is, let's make sure we get the right spot here. That is right in that area, right there. Okay, I'm gonna mark this with a Sharpie. Right in here. Okay. So the heat is coming from somewhere in this general area. I'm thinking maybe this chip, but I couldn't really pinpoint it to that. According to the thermal cam, it looked more like it was like right in this area, which doesn't really make a lot of sense because there's not really anything there. So I'm thinking maybe we need to remove this. We've got a short on this pin and these pins here, and then this pin, and this pin. On the other side, the heat was coming from this general area, and as you can see, there's just nothing here. This is a coil. Coils generally don't cause shorts, and they're not connected. Like this side of the coil is not connected to ground. So this is just, this just goes all the way through. It's just a coil of wire in there. So this diode is shorted, but that's also kind of what I would expect in this sort of circuit where we know that there's a short here. It is possible that this diode is faulty, but if that was the case, I would expect the diode itself to get really hot, and it is definitely not. So I think our best bet is to remove this guy and then we'll retest for shorts. And with that component removed, let's see how the heat looks. We get no warm spot in that area. There's just nothing. That chip we took off is from right here. That's right about where the warm spot was. And without that on there, we don't get a warm spot anywhere on the board. So now the problem is that this little guy right here, 4S0101, there is nothing online about this. So I can't find parts, I can't find a schematic, I can't find anything for this. I don't have a donor board that I've found that has this on it. So unfortunately, we can't replace this and test it anymore because I can't find one of these. There's a chance that just replacing this could fix it, but also there's a pretty good chance there are other problems on the board. But unfortunately, without one of these to replace it, we just can't go any further on this one. So while this one is potentially fixable, since we can't get parts, there's just nowhere we can go on it. So let's move on to the first Apple computer. And just to show, I was able to get this thing all the way back together. It was kind of a pain, but really not too bad. Now let's move on to the MacBook Pro. So far, we're 0 out of 3. Let's open up this MacBook Pro and see if we can fix our first one. And our screws are out. Back cover is off. Let's see if we have any clues on this board. I dug out my old MagSafe cable, so let's plug it in and see what happens. Oh, we get a green light and fan spin? Does this thing have a display? No display. And we get an orange light, so the fan stopped. I mean, that's something though. Let's see what happens when we try to power it on. Okay, we get nothing when you try to power it on. Try to hold the power button down. Yep, just nothing. But we do have a little bit of life on this board. So I think it will take this board out and have a look at the other side and just see if there's any burn components, any components that are obviously broken, and then we'll move on from there. Okay, and I unplugged it and then plugged it back in, and this is what we get. Battery's charging, it is low charge, I know that much, but now this thing's working. Trackpad works. I'm gonna let this charge for a little bit and just see if this charge percentage goes up and see if the charging circuit is fully working or not. We do need to have a look at that USB port though and see if we can figure out what's going on there and see if we can figure out what part of it is blown. So let's get under a microscope and do that next. So right down here is the USB port, which attaches to the board right here. And if we look at the board a little further back, we see this guy. Right here, you can see the half of this thing has just totally been blown off. Now there is another USB port over here, and this is the same component, 0502N. And if we look at this component on AliExpress, down here it says diode circuit protection. So it looks like maybe Apple actually has some circuit protection here. Now luckily, I do have an old donor board for this laptop, so I pulled that component off of that laptop, and we're gonna place it on this one and see if this USB port will start working again. So I'm gonna use my hot air soldering station to heat this up until the solder melts, and then we'll pull this component off and place the new one. First, we'll flux it up with just a little bit of flux. That'll just help the solder flow. Come on, almost, there we go. And now we will place the donor component. And we put it upside down. It might not matter on this one, I don't know. But we'll get it placed correctly. Just use a little more flux. And I'll heat it up one more time just to make sure it's getting plenty hot and the solder is connecting really well. There we go. Now we can start this thing back up and see if the USB port works. And with that replaced, let's first test the USB port that we didn't fix, or didn't try to fix. And we have 5 volts coming out of it. Just like that. Now let's test the USB port that we did try to fix. And we have 5 volts. So it looks like Apple may have done something right and put circuit protection right in the USB circuit and probably saved this laptop. This is an older laptop though. Let's take a look at the newer one and see if they still have that same circuit protection there. And this one is still working just fine, and we're at 22% on the battery, so the battery is also charging. Now before we get doing anything too crazy, let's just plug this MacBook Air in and see if it charges. Oh, orange charger. Not that we can see that on camera. Let's see if I can get that. There we go, you can kind of see it. Okay, good so far. Let's open this thing up. See what happens when we try to turn it on. Definitely nothing so far. Okay, so we get charging, but nothing's going on the computer itself and it's not starting up. Let's get this back cover off and have a look to see what's going on in here. And with those screws removed, we've got some pretty tight clips that I had to pry up, and then we just pull back this way and the bottom cover comes off. That is so clean looking. Gotta give it to Apple. That's a nice looking inside of a laptop right there. But did they design it so it'll withstand the USB killer? Over here are the USB ports. We gotta get under here and have a look at the board. So we're gonna discontinue charging for a little bit while we remove this logic board so we can have a look at both sides of it. We got a bunch of screws over here, a bunch of little covers, screws, covers, screws for the board. So we got a bunch to do. I'm gonna first start by disconnecting the battery. There we go. There we go. And we'll disconnect the USB-C ports. Just using my fingernail for this. And the charge. And the MagSafe connector. And then disconnect the MagSafe. Oh, we got a hidden screw in the middle of this guy. That's sneaky. And with all of those disconnected, now we can remove each of these screws that hold down the logic board, and then hopefully we'll be able to pull this thing out. And with all of those out, I think this logic board, oh yeah, okay, should come out. And, oh, almost. There we go. There we go. Okay, easy enough. And then we just pry off this whole metal plate right here, just like that. And there we have the logic board. And I think it's time to get under a microscope and have a closer look at this. So the USB-C ports plug in here and here. And right up here is where the MagSafe plugs in. And then over here on the board, we've got a CD3217B13. My understanding is these are the chips that help determine what the input or output is on the USB-C ports, and that's what controls them. So let's start checking around these chips for shorts. I'm going to do these big capacitors right over here. Okay, and no short on that one. Next we'll go up to this chip and do the same thing. Oh, here we go. That is definitely a short. Let's check this other one. And no short on this one. So this area right here seems to be a problem. I think most likely this chip is faulty, but unfortunately there's not really a good way to tell. I'm guessing what probably happened is all the voltage came in through the USB kill and killed this chip, and that is why this chip is shorted, or one of these components around it is shorted. Unfortunately on this board there is no circuit protection, so it's not just a matter of replacing one of these little chips. It's this fairly large BGA chip that I think probably needs to be replaced. I've looked around this board quite a bit and I don't see anything else that looks like any sort of problem at all. There are no burned or blackened chips anywhere, so I think my diagnosis on this one is that most likely this chip is faulty. Unfortunately, I don't have any of those chips, and I could take this chip off to see if that short goes away, but I don't know if Austin Evans wants this board back or this MacBook Air back, so I don't want to remove this chip because it is a BGA chip, so once I remove it, I can't just put it right back on. So unfortunately, since there is no circuit protection on this logic board, we're not going to be able to fix this one. But let's move on to one more Apple device, an Apple iPhone. While we're letting our blue heat mat heat up, let's see if we get any voltage going into the charge port when we plug it in. And we get nothing. All right, let's get this phone opened up, see if we can figure out what's going on. To do that, I'm just gonna let it heat on the heat mat. Then I'll use a suction cup to remove the screen. Then we'll take a look at the inside. But first we need to remove these two screws on the bottom. Now I'll just let it heat up for a few minutes, then we'll get the screen off. All right, it's been heating for a couple minutes here. Let's see if we can get this screen off now. Need to create a little gap, which we do have a bit of a gap right there. So, need to create a bit of a gap, and then we'll put a pick right in there. There we go. And then we'll see if we can get some more of these in here. There we go. Now we just need to work our way around. And that will slice through the adhesive, and we can get the screen off. Okay, we got it a little bit loose. Now we'll remove the suction cup and need to get it loose the rest of the way, and then we can pull it off. There we go. So one little corner up here is still attached with a little bit of adhesive. There we go. And there we go. Now we can start taking it apart and have a look a little closer at the inside. All right, now we're going to use a Phillips 000 to remove this cover. Then we'll disconnect the battery. And then after that, we'll disconnect the screen. So battery connector is right here. That is now disconnected. Now we can disconnect the screen from there, and then we need to remove this little metal cover so we can disconnect this cable right here. And there we go. Almost. One more screen connector. And there we go. So what I'm gonna do next is disconnect this cable, which goes down to this charge port right here. And I want to remove all of these little components right here so we can get down to this little charged circuit board and have a little closer look at that and see if that's the problem. Unfortunately, I don't have another charge port laying around, but I do hope that we'll be able to see if there's been anything burned or blown on the board. This is actually the first time I've taken one of these apart. Not the first time I've taken an iPhone apart, but this specific model. I'm hoping I can get all of this stuff off pretty easily. I don't know exactly what I need to remove to do this. It's this board right down here that we need to get to though. So we need to remove this, maybe the Taptic engine, probably this piece, for sure these two screws, and then maybe we can get to that board. Now that standoff screw removed, I'm hoping, okay, we got that part. Is that all loose now? Yeah, that's pretty loose. But how can we get that part off of there? Okay, we need to disconnect this connector. All right, there we go. Oh, actually, that just comes up with, that whole thing comes up with like that. Okay. So I'm not sure if this can come out without the logic board coming out. Almost. Come on. There we go. Okay. So that we need to disconnect as well. There we go. And now the Taptic engine looks like it needs to come out next. Okay, that's connected right here. All right, there we go. Now we're almost down to the charge port, which is connected to this whole ribbon cable right here, which means we might need to get to the motherboard anyway, although we can probably just look at this under a microscope as is. Okay, I think that's apart enough for us to take a look at this thing under a microscope. Okay, so here's the lightning connector. This is where the charge cable plugs in. There's a bunch of little components back here that we can't see because it's filled with this epoxy that's basically impossible to remove without damaging anything else. If you try to remove it, you can damage these components or tear the cable itself that these are mounted on. So we're not gonna do that, but just looking, I mean, I don't see anything obvious that's burned here. Not that we can really see that well. These guys over here all look fine. Don't see any problems there. So then if we trace these traces over here, they go all the way over here under the board, and then they connect right over here with this connector that I've already removed. Don't see any burn spots on the connector on the cable side or the logic board side. And if we move this adhesive foam pad, we can see a few more components down here that, I mean, we can't really tell very easily whether there's anything going on with them. It's got kind of this also epoxy on it, so it makes them look brown, but they're not actually blown. It doesn't look like. Now, unfortunately, like I said, I don't have another one of these charge ports and flex cables to replace this with, but I feel like it's probably unlikely that there's a problem on this part. I think there's probably something going on the board, and that's also a much more in-depth and difficult repair. So unfortunately, we're not gonna be able to fix this iPhone today, but I think we have a better chance at fixing the next device coming up, and that is the Nintendo Switch Lite. But I do want to show the iPhone all back together. So this is it with all of those pieces back in. Now I'm just going to fold it up. And then the screen can snap down. Just like that. Now we just got these 2 screws at the bottom. And we'll be done. And there we go. Now we can move on to the Switch Lite. First thing I notice is I don't know if there's a faulty screen in here, or maybe that, I don't see a screen protector on here. That could be a problem. But let's plug this in and see what happens. 14.8 volts, 0.3 amps. Okay, that's not the worst thing. Definitely getting nothing when you try to power it on. But it is taking a charge. Okay, I think the only answer here is to take the back cover off of this thing, have a look at the board. And some of the screws in this are already out, so I mean that makes the job easier. All right, those 2. We got one over here and one over here. And that screen is just barely hanging on in there. I'm not sure that screen is even good, honestly. Okay, this is all loose. There we go. Now let's get this metal plate off and then we can have a look at the board. See if we have anything going on in there. So far the charging seems mostly normal, so I'm not sure what's going on or why it's not turning on, but I'm hopeful we can get this one fixed. Okay, here we go. Let's start by checking the voltage on the battery. We have 3 volts, so that is a very discharged battery, so that's part of the problem. So the first thing I'm going to do is get this battery charged up, then we can go from there. Now as I'm looking at this ribbon cable is completely disconnected, and there's also this ribbon cable over here is also completely disconnected. In Austin Evans' video, he did show this Switch Lite turned on, and it showed something on the screen, but I'm pretty sure that's a screen ribbon cable over here. So I'm going to get this heat sink and heat pipe removed, and we'll get that figured out while this is still charging. And if you ever do this yourself, don't do it while it's charging. Disconnect the battery first and everything. You don't want to be messing with these ribbon cables and screws and stuff with the battery connected. Yeah, there's no connector. There's no ribbon cable flipped up here. So I'm thinking they must have taken this apart before they sent it over to me or something. But either way, we got to get this connected before we're going to be able to really test this thing much. So after looking at this a bit more, this is the screen cable. This is the digitizer cable. I'm not sure how this doesn't have a digitizer cable to connect to. I'm not sure what Austin did to this thing, but there should be a digitizer cable there. Either way, we should be able, at least be able to get this thing to work as is without that cable there. So now that I've figured that out, I'm going to continue letting this thing charge, and then we'll start doing some testing. Now while this thing is charging, I decided to get out a thermal camera to take a look. We got 143 degrees right there on the board, and right over here it's very similar. So kind of like right behind that screen connector, we've got 142, 143. That is pretty warm compared to the rest of the board that's more like in the 120s down here, low hundreds, and down here, yeah, also 120-ish. But up here we definitely have a hot spot. So once this is charged up a little bit, I'm going to remove this board and have a look at this area right here. So let's get this board removed so we can have a look at the other side, see if we can figure out what's going on. There is a power management chip over there. I don't remember if that's where it is or not, but we will find out soon enough. One of the problems with switches and switch lights is that sometimes when you have voltage come in like that from something like a USB killer, or even just like a power surge or something like that. Since there isn't sufficient protection on the board, sometimes that can go right to the main chip and kill that. So hopefully that didn't happen in this case, but we will find out. Okay, and now the board is out. We can have a look at the other side and see what's going on. And right about here is where the heat was coming from, because it was right here and right here, kind of around this connector. And if we flip the board over, that's right where this power management chip is. I'm going to plug it in and let's see if we can pinpoint it any further. It is possible that one of the capacitors around here is shorted, but I feel like it's probably the chip itself. So looking at this, when I have it on the chip itself, we have about 100 degrees. But then when I go up from the chip slightly, we have 144 degrees. Let's flip this over and see if we get the same hot spots over here. Yep, same ones here. So it is possible that that chip itself isn't what's faulty. Maybe it's something else. Yeah, we got 153, 152 degrees. So I think we should have a look under the microscope and see if we can see anything with a visual inspection. And here is that chip under a microscope. Let's take a look at some of these capacitors. It seemed like over in this area is where the problem was. So if we go here, yep, we got a short there. Not there. So we got a short on this one, a short on this one, a short on this one. So that's, I don't know, that chip definitely could be faulty, but also there could be a bunch of other stuff shorted. Let's go take a look at the M92 chip. That's what sort of controls the charging. No short so far. Okay, that's shorted, and that's shorted. Now, I'm not totally sure. This one, maybe that's normal to be shorted. I don't think it's normal for this one to be shorted, so it kind of makes me question this chip. But the other thing we have is, look at this little guy. This guy is toasted, and there is no continuity here. This should be, this is, there's basically little coils inside here. And so this should be basically very little resistance from this point to this point that goes through that little guy. So that is definitely a problem. And that looks like maybe it acts as a fuse, but clearly it didn't do a good enough job in this case. So I think the first thing we'll do is remove the M92 chip and then see how many shorts we have left. And with that chip removed, let's see if our short is gone. It is not. Okay, so the other thing with this chip over here is that this capacitor right here, I checked with another board and it actually is shorted too, so this just may have low impedance. This capacitor, however, was not shorted, so that is definitely worrying. I think what I want to do next is remove this capacitor and then just see how this chip responds and whether this hot spot is still here. So I'm going to do that next. I will replace the M92 chip and just put it back on where it was. And then also I need to install another one of these little guys right here, this little coil. So I'll do that as well. and the M92 chip is reinstalled. I went to replace this and I totally blew it because my hot air blew it all the way off the board and somewhere into my workbench, and it's so small, I have no idea where it went. So we'll worry about that later. And we do have this capacitor removed. So let's see if this board still gets really hot. So when I plug in the board, let's see what happens. Oh, that immediately lights up. Yep, that gets hot real fast. Although I feel like that's hot in a different place. I feel like before it was down here, but maybe I just had it oriented differently. Definitely got a big hot spot there though. Now as I'm looking at this, where this other hot spot was, it was right around here, and looking at this capacitor, it looks like maybe there's a crack in it. I mean, I can't tell for sure, but let's remove this and see what happens. And let's test this without the capacitor. Still shorted. That's a bummer. Let's try removing this coil and see if that does it. This was where it was hot, so hopefully that'll do it. Usually coils don't go bad, but this is definitely an extreme case, so. And there's definitely a short there that shouldn't be there. Now we'll check and see if this still gets warm with that coil removed. And I think I misspoke in the previous scene where I was removing the coil. Coils are gonna be shorted from one pin to the other just because it's just a coil of wires. So there's gonna be very little resistance there. But with that removed, that disconnects this chip from this circuit right here. So let's see if it still gets hot with it removed. And yes, it does. We still got a hot spot there. Okay, so let's just remove some more stuff. And with two more components removed, we still have a hot spot. We got 150 degrees here and 120s all around it. So there's still something going on here. I'm not sure what component is causing this hot spot because we've taken off all four of the little components that are the closest to this. So maybe there's a problem on the other side of the board. I don't think so, but yeah, it's just more generalized heat on the other side, and we only get 120s on the other side of the board. So I feel like it has to be on this side, and it has to be one of these components right up here. So I guess we'll just keep taking stuff off until we can get this thing to go away. So let's try something else here. Instead of looking at the heat, since it's really hard to pinpoint, I have a cotton swab soaked with isopropyl alcohol. I'm going to put on this whole area. And I think it's pretty clear what's getting the hottest, the fastest. That chip just immediately dries this alcohol right up. This area over here definitely does, but the chip for sure does it much faster. So I think that heat we're seeing on the thermal cam is being generated by this chip. So I think the next thing we need to do is remove this chip and replace it with a different one. Let's just see what happens. So what I'm going to do next is use my hot air soldering station to heat this chip up until the solder melts. Underneath there's a bunch of little tiny solder balls, so that's the solder that's going to melt. And then I'll come in with a known working chip, install that on there, and then we'll test it and see if it works. We've already got flux on this chip. I'm going to add a little bit more just to make sure we get a bunch of flux underneath the chip. That'll just help all the solder balls release. Hopefully not stick together or anything like that. So just going to heat this chip all up till that solder, all those little solder balls are melted. And I can just pull it straight off with my tweezers. Okay, there we go. Oh yeah, that looks great. So I'm going to kind of line it up about where it needs to be, and hopefully it won't keep sticking to my tweezers. There we go, okay. Now I'm going to get it lined up. Then I'll bring the hot air in and heat it up. That's getting pretty close. Okay, I'm gonna come in with a little bit more flux. Just kind of flood the whole area with flux. Then I'll heat it up again, just to make sure it's in the correct position. Give it a little tiny nudge. Yep, we're good. And even with a known good working chip, we still have that hot spot right on that chip. That tells me that there must be something else going on somewhere else on this board, but unfortunately there's just no way for me to know where it is. So once again, instead of having a circuit protection component somewhere near the input charge port, the manufacturer of this board has not done that, and so that high current and voltage traveled through the board and blew something out somewhere, but there's really no good way for us to pinpoint it other than the things we've tried, and unfortunately that just hasn't worked. So I'm gonna get this Switch Lite put back together. Let's take a look at the PlayStation 5 and see if we can fix that one. I'm pretty sure I already know we can't because I sort of know how the USB ports work on the PS5, but you never know. Let's take a look. Since I already know probably what's going on with this PlayStation 5, I'm just gonna take this thing apart, have a look at it. Just need to get down to the motherboard so we can see if what I think is wrong is what's actually wrong. Ooh, this one's never been taken apart before. And with all those screws out, we can start taking pieces off. I'm gonna use a pair of pliers to grab the white part and the connector where the wires go in, not the connector attached to the motherboard, to pull that off. And the fan can come out. And then this whole top piece should come off just like that. And now we need to remove these 43 totally necessary screws around this metal plate along with these antennas. And then we'll finally be down to the board. And with those screws removed, we can remove the top plate. And then we need to remove the clamp, and then we can get down to the board. I mean, down to the top side of the board. We're already down to the board, I guess. We can remove the board after this. There we go. Let's flip it over and have a look. Interestingly, we do show sort of a dry spot starting on the APU right there. But let's take a look at these USB ports, and I'll show you why they're a horrible design. So right here is one of the USB ports on the board, and right behind that we have where it mounts to the board, and over here we have a little device that kind of looks similar to the Switch Lite, and then we also have this device right over here. So you would think that that could be a circuit protection device, but if we come through and test, there is continuity through it like there normally would be, so that's not blown. This little guy right here is also not blown. Let's check the other one. Same. Same. So then these traces go through the board right here. So we'll go to the other side of the board, which goes to right here. And if we follow them back, they go right into the APU. So instead of designing these boards with some very cheap circuit protection devices that actually work, they've decided to exclude them and make it so a power surge, whether it's from a lightning storm or a USB kill device or something else, that power surge can cause the entire board to burn out and your $500-ish device is now useless. So unfortunately, I was only able to really fix one of these 8 items that were killed by the USB kill device. Now there are more skilled technicians that probably could have fixed a couple of these, but ultimately I think this video shows how manufacturers are kind of skimping out on circuit protection for their devices. The other thing that we learned today is that the USB kill device is very dangerous and not something to be messed around with, as it can kill devices very quickly and easily without really being able to tell what actually killed them. Thanks again to Austin Evans for sending these devices over. I have huge respect for Austin and his team for what he's doing over on his channel. If you want to see the video where they killed all of these devices using the USB kill device, I'll put a link for that video up on your screen now so you can go hang out over there and see how it works. Thanks again for watching today, and I hope you have a good one.